In this video, we're going to be applying square roots, and we're going to start with the Pythagorean theorem. Here's the Pythagorean theorem. It says if you have a right triangle, then the sum of the squares of the lengths of the legs will be equal to the square of the length of the hypotenuse. And this is often referred to as a squared plus b squared equals c squared. Let's look at a picture of this to help make sense of what it's saying. When you have a right triangle, and you know it's a right triangle because there's a little box down here in the corner, and that's trying to tell you that these lines are perpendicular, and so they're meeting in a 90-degree angle. The triangle has two legs and a hypotenuse, where the hypotenuse is the longest of the three sides. So the way the Pythagorean theorem works is you pick one of the legs and decide that that's going to be your A, and then the other leg becomes your B. And it doesn't matter who you pick for your A or your B. For instance, if I decide that this is going to be my A, and I measure its distance, then this has to be my B, and I measure its distance. Because the Pythagorean theorem says that if you measure the distance of A and square it, and then measure the distance of B and square that, and add those together, you'll get the distance of the hypotenuse, which is referred to as C, squared. So you'd measure C, and then you'd square that distance. And so we measure this distance and square it, and we measure this distance and square it, and then we add those together, and it'll be the same as measuring this distance and squaring that. Now, at the end of our course, you'll be able to solve equations that have second powers, but for now, we're not there yet. And so what we're going to have to do to use the Pythagorean theorem is we'll start with two different forms. One of them will be for finding the length of the hypotenuse, and that's the one where we have C isolated. And then the other will find the length of a leg, and that's when we're looking for either A or B. And again, it doesn't matter who's the A and who's the B. So you can always find the length of a leg using this form. This will just be the length of the other leg, the one you're not looking for. It'll have to be given to you. So for example, if we were trying to find the length of the hypotenuse for this triangle, I would have to look at my two different forms for the Pythagorean theorem, realize that I'm trying to find the length of the hypotenuse, so I'm going to use this one, and that means I need a distance A and a distance B, and those are the distances of legs. And if I look here, sure enough, these are the shorter two sides, so I would start with this form. You might say A is 5 and say B is 6. And again, it won't matter if you say A is 6 and B is 5. I guess I'll choose and say I'm going to let my A be the 6 and B be 5. So I fill those values in. And then I have to follow order of operations. I'm going to have to simplify the radicand first. 6 squared is 36. 5 squared is 25. I add them together. I get the square root of 61, which is close to 7.8. So the length of the hypotenuse it's exactly the square root of 61 miles, but that's about 7.8 miles. See if you can do this one. I always like to draw pictures when I have a situation like this. So I've got a ladder, I'm going to lean it up against a house, and I'm so far away from the wall. So here's my picture. Here's my ladder. It's 20 feet, and I've leaned it up against the wall of the house here. And I know that the end of the ladder here is 6 feet away from the wall because it tells me that right here. And then I'm trying to figure out the distance from the ground to the bottom of the window, and that's going to be right here because it tells me that the ladder is just right at the bottom of the window there. So here's my ladder. I'm 6 feet away, and I'm trying to figure out this distance here. I have two forms to choose from. This is a leg, so I'm going to have to choose this form since I'm trying to find the length of a leg. So I'll write that down. And then C is the hypotenuse distance. That's going to be 20. A is the other leg that I know. That's going to be 6, so I put those in. I then simplify using the order of operations. This will be 400 minus 36. That'll turn out to be square root of 364. And I'm going to use a calculator and find that that's pretty close to 19 feet. And so from the ground to the bottom of the window is about 19 feet. One of the uses for the Pythagorean theorem is to decide if something is square. Square means you have 90-degree angles. So say you're building a deck, you'd really like the deck to be square. And that's what we've done here. We've built a deck, and it's 12 by 16. And what we're going to do is, once we've built this deck, it's 16 feet and 12 feet, we'd like to know are these 90-degree angles. And so we're going to measure from one corner across through the middle to the other corner. Now here's the question. If these are actually 90-degree angles and you have a right triangle, what should the length of this be? See if you can figure it out. This time I'm looking for the length of a hypotenuse, and so I'm going to need this form right here, and I'm going to fill in my two leg lengths, 16 and 12, and then I follow the order of operations. I square both of those, I add them up, I find the square root of 400, which happens to be exactly 20. And so this deck will be square if this distance turns out to be 20 feet. Here's another example. A real estate agent wants to measure the distance from one end of the lake to the other. So she drives from here about 1.4 miles and then takes a left and drives to the other end of the lake, which turns out to be about 1.9 miles. Can you figure out the distance across the lake? Again, we're looking for the hypotenuse, so we'll start with this form. I'll put in my leg lengths. I'll square and add. That's the exact distance in miles. I'll use a calculator to get an approximate distance, so it's about 2.4 miles across the lake. Well, that will conclude this first video where we practiced applying roots using the Pythagorean theorem.